Hey everyone, this video is supposed to be a brief tutorial on how to get started with FRC programming. When I was on 747, my first year was 2018, my friend and I did not really have any resources on how to learn to program, and I found this awesome YouTube video that's going to hopefully do what I am going to do in this video, and I'm going to do a more condensed version of it. The video doesn't seem to exist anymore, and it doesn't really apply because it's from 4 years ago. The code is a lot different, but that basic video allowed for us in our first ever meeting with the robot to reprogram the 2017 robot from something that was just like that we had no code on it to something that we could drive around, use all the functions like the intake, the shooter, and everything. And we even wrote some basic autonomous. So in this video, I'm just going to show you how to create like a project, add some libraries that you need, how to make a motor spin, use a joystick, add some buttons and stuff like that. So we're gonna get you guys ready. And I bet by the end of this video, you guys will feel a lot more confident with FRC programming. So before this video, we should have helped you guys get set up with the software and everything. So by this time, I think that all the software should have been dealt with. So if you have any questions, you can just ask us while we're there. And if you have any problems while watching the video, you can ask us. That's fine. So the first thing we need to do is we need to make a project. So when you open the WPILib here, you can see it on my desktop. It looks like WPILib VS Code. Uh, or is that what it says? Yeah, WPILib VS Code. You can press this little button in the top corner. It's the WPILib command palette, and this is a button that's exclusive to WPILib's VS Code, and it has a bunch of useful like functions that optimize a lot of the things we do. So one thing is we're going to type in create a project, and that's that. So you have to fill this out. So we're going to select a project type. What we normally do is a command-based project, a command robot. You don't need to know what commands are yet. It's a structure. These are just structures for how you want the robot to run. So a timed robot just runs on timing. So every certain amount of time, certain things are going to be called. A command robot is a lot more. It's really what everybody uses. It's a robot that has defined loops. So every 20 milliseconds, there's this thing called the scheduler, the command scheduler, that handles a bunch of whatever you tell it to do. So like when a button's held, it'll run this command. It just makes everything really clean. But for now, we're not going to be concerned about what that is. Just select command robot. Choose a project folder. So I'm going to choose inside my documents. I'm just going to go to I made this folder before, FRC. So we're going to make that the project. We'll make our project name demo project. You can make it whatever you want. Create a new folder. Team number 1923. If we're using the 1914 robot, do that. I'm pretty sure we're going to be using the 1923 robot or whatever robot in the future is being used, and click generate project. I'm going to open a new window just because that's easier for me, but that's fine, so it doesn't really matter. So the first thing we're going to do is we're going to take a look over here on the side. All of the code that we're concerned with is located inside source and Java FRC robot. So this is where everything is done. Right now, the only thing we're concerned with is the robot class. These other classes are important and have things in them that you can use in the future. But for now, for the basic stuff, you really only need the Robot.java file. You can really do almost anything in here. It's just for cleanliness and making sure things don't break and they run well and autonomous. You want to do things in other classes. But for now, this is fine. So let's just take a look at what this class really is. We've got a few methods in here that have some descriptions. And these methods are pretty well defined. So robot init is a method that is called once when the robot turns on. Robot periodic is called every 20 milliseconds. That they said it runs from the scheduler, but that's pretty much every 20 milliseconds. It'll run every 20 milliseconds the robot is on. Disabled init is whenever the robot's disabled, whatever you do in here will be run. So if like you want to say turn off all motors, you could have written a method beforehand, and anything that this will run whenever you do disable inside the driver station in here, which you have to open. But this comes with the software. Disabled periodic, whenever the robot's disabled, it'll run every 20 milliseconds. So that's 50 times a second if you don't want to do the math. Autonomous init is when the robot is in the autonomous mode, it's going to run once or enabled. So if you were inside autonomous and you enabled the robot, it would run once. Periodic is as it says, when it's inside autonomous mode and enabled, it'll run every 20 milliseconds. This is getting pretty redundant, but teleop init will run once when teleoperated mode is enabled. Periodic is every 20 milliseconds, and then these test modes we don't really care about, but these are just if you're running the test. It's like a separate thing for testing, and then simulation, you can simulate the robot, and it just does things specifically in there. So the first thing we want to do, I think the most basic thing, is making a motor spin. This was the first thing I ever did. It was terrifying because I realized that when you turn a motor on, it doesn't turn itself off automatically, and you're going to see that. So What we're going to want to do is, actually, I forgot, we have to install the libraries to control these things. So the first thing you need to do for that is to press the little button in the top corner, type in manage vendor libraries, and there's a few ways to do it. If you install the software from CTRE, Cross the Road Electronics, I will put the link. You can find the link just by Googling it, but to find the link, I can go like this, CTRE library, and you'll see it right here. If you scroll down, you'll find the thing right here. It says, alternatively, you can use install new libraries online option with this link. So we're going to right click and copy this link. You're going to go up here, manage vendor libraries again. I used it last, but you just would have to type that in. And then we're going to go install new libraries online. And then you can paste that link in there and press enter. And it's going to say it's recommended to build it after. So just do that. I had an error last time I did this. It was just a bug, but it should be fine. See, build successful. And even you want to prove that it's in there. You'll see it right here, phoenix.json. That's the file that contains all of the code that's necessary to control the Falcon motors, which are on our robot, on 1923's robot, we only use Falcons this year. In previous years, there's other motors, like one's called a 775, one's called a Sim, there's Neos, there's the Falcons, as I mentioned. So there's different ways you can control these motors, but on this robot, and hopefully in the future, we're only using Falcons, so you don't have to worry about that. So what we need to do is we need to define a motor. So I'm going to call it private. Normally, I'm not this good about my public and private stuff, but I'm going to do it just for hopefully some good practice. We're going to define a new Talon FX. The Talon FX is a speed controller. It is a device that takes in power and outputs a percentage of power and does all the math on it to calculate how fast the motor should spin based on what we're telling it. It's built into the motor. So the Talon FX controls the Falcon motor. So we're going to define this object. We're just going to let's call it motor1 equals new Talon FX. It takes in something, as you can see. It takes in a device number. There's a unique number that each motor is identified with, and this is done inside the program Phoenix Tuner. I think I have it installed. I don't actually have it installed, Phoenix Tuner, but right now on all of the robots there should be little stickers on the motors. If there's not, you can use the program Phoenix Tuner. It can be gotten at this website right here. I think it's software reference manual. You can download it in here, Phoenix Tuner. And what you do is you just plug right into the robot using a USB cable, and this list will pop up of all the motors and their IDs, because each one's given a unique ID. And you can do blink, and you can press the blink button, and it'll make the lights on the motor physically flash. So you'll see which motor's motor 0, which motor's motor 1, and whatever. So let's just pretend we're going to do 0. That's probably, normally on our robots on 747, 0 would be the left front drivetrain motor, because there's a few motors per side of the drive of the robot. So we're going to make it this. We're just going to define motor 1 as that. So now what we can do is, let's say we want to go down to, what do we want to do? Teleop init. So what this is saying is, inside when teleop is initialized, so this is called once when the teleop mode right here is enabled, we're going to do something. Right now, what all it's doing is it's going to see if there's an autonomous command running, and it's going to stop it. We're not concerned about that. We're just going to leave that. But what we can do is we can say motor1 dot set, and then inside here it takes two inputs. One is the control mode, so we're going to do control mode dot, and then there's a few options. You can control it using velocity, position. Like you can tell it what velocity you want and rotations per minute. You can tell it what position to go to based on like the encoder ticks, which is the sensor inside of it. You can tell it how much current to draw. I thought there was a voltage one too, but I guess not. But you can also do percent output. That's the simplest one. And percent output takes in a number between -1 and 1, or a double, so like a decimal number. So it could be -1.0, or it could be to 1.0. So if we want to make it 50% speed forward, we do 0.5, right? Because forward is positive. And in terms of motors, just so you're all aware, forward is counterclockwise, I believe. So if you do 0.5 positive, that's going to spin at 50% of the maximum speed of the motor counterclockwise. So before you do anything with this, make sure that the robot and the motor that you're controlling has everything clear out of it. Like try spinning the wheels or whatever you're controlling first, and make sure nothing's touching. If you're moving a drivetrain motor, make sure that it's on the cart so you're not gonna move the robot physically. So once you do this, what we're saying is this: the robot is enabled into teleop, and we're gonna set the motor to be at half speed, right? So that's all we're doing right now. Now what you would type, you click this button in the top right corner. Well, firstly, actually, you'd have to connect over the radio or Ethernet or USB, which is just, if the robot's powered on, it should just show up on the list over here. You connect to it on the network. it's just it just looks like a Wi-Fi network. And then you go up here and you type deploy robot code. And you press enter. For me, I'm going to get an error because I'm not connected. You'll see. But yours should hopefully just say build complete. At that point, I'm going to do what's called simulating robot code. Yours, you don't have to do this part, but you would do this part. You'd open the driver station. For me, I have to open the driver station and the simulator, but you don't have to worry about that. It's going to look like this. You're going to see these greens saying you have communications, saying you have robot code. You're probably going to have red for joysticks because you won't have joysticks plugged in. I do, because I'm going to show you something with that in a little bit. But then you just enable teleop. And what you should see at this point is whatever motor you had plugged, you decided to make spin, is now spinning at half speed. And it's probably pretty loud. And if you did not put it up on the cart, it's probably driving into a wall. And that's scary. So you want to disable that. But you understand, you see it work. That's the first thing. You've controlled a motor, right? Some safety things. Before you enable the robot for the first time, always say, hands clear, I'm enabling the robot. Make sure everybody hears you and make sure everybody is aware of the fact that the robot is going to be enabled and a motor is going to be spinning and we're not sure if it's going to work, right? Even if you're sure, even if you think it's going to work, make sure you emphasize the fact that the robot's going to be enabled. Second thing, you always want to have someone, if you're not the one, you normally work in groups of people, but I'll have someone either with their mouse on the disable key or if you press the button enter. So if I press enable, I'm not using my mouse. I'm going to press enter. That disables the robot. So you want to have someone on the kill switch essentially. And this is important just in case, we don't want anyone getting hurt. So make sure your hands are not on the robot. You don't have any long sleeves or anything or hair in the robot, back up and then make sure that someone's on the kill switch. So that's the first thing. We've made a motor spin. Congratulations. This is the first step that a lot of kids go through to programming an FRC robot. When you think about it, a lot of kids don't even get this far. You're probably in the top 20% of kids just by making a motor spin. You know what I mean? A lot of kids give up before they even get here. So we've made a motor spin. What's a little bit more cool than that? Maybe controlling it with a joystick, right? So why don't we make this motor be able to vary in speed based on a joystick? What I'm using right now is a flight stick. So if you don't know what a flight stick looks like, it looks like, I'm using this exact one actually, this exact brand, a Logitech flight stick. It's a USB powered flight stick. This works the same as an Xbox controller or a PS4 controller. It just has different buttons. And there might be a few more buttons on this than on an Xbox controller or vice versa. And this has a few more axes of rotation, but otherwise it's the same. There's no difference in terms of programming. So I'm going to be using this. And you should just probably use a gamepad or Xbox controller. So what we're going to do is we're going to define a joystick thing. Oh, one more thing. Also, I forgot. If before you had an error underneath this red squiggly line, try hovering over it and doing quick fix. You'll see like this. Oh, well, let me give it a name. Let's just do it like this. We'll call this controller. Equals new joystick. And what it wants is a port number. But I guess it's automatically importing for me because I'm pressing enter. But if it didn't, you just hover over it and do quick fix and then do import. So it's asking for a port number. Now, how do we know that? We're going to have to go and figure that out. So let's open the driver station. And I unplugged it just to show you. You're going to go, this is your driving section. You want to go to the USB tab right down here. And I'm going to plug in my joystick. And you're going to see it show up. So let me plug it into my USB port on my computer. Okay, so it shows up just like that. It's a Logitech Extreme 3D. Right now, as you can see on the left, it's on port 0. So I'm going to change this to port 0, semicolon. So that's done. Now we have a controller. Let's scroll down. So what do we want to do with this thing? Let me comment out what we did before, because we don't really care about that anymore. And let's move to teleop periodic. We want to change what's happening every 20 milliseconds, because what we're doing here is we're just setting the motor to be on. We're never telling it to stop. We're never changing the speed. Just at one time, right when the robot's enabled, we're setting it to 50% speed and there's no control. At this point, though, let's change the motor speed based on the joystick position, how far forward we're pushing it or pulling it back, and let's make something cool happen. So what we're gonna do is we're gonna make a variable. You don't have to do this. This is little. You can directly pass these things in, but this is just for clarification. Let's just make a double and let's call it y-axis position. I know it's the y-axis, but to prove that it's the y-axis, let's open the driver station. And if you click on it, you can see I'm going to tap buttons. Right now, you see the buttons being pressed. You'll see them showing up. I'm just tapping random buttons. But if I want to move the joystick, you can see the different axes are changing. I'm moving it. This is forward. This is backward. This is left. This is right. This is me twisting the stick. And there's even a little slider in the bottom corner I can control. But what we want to control is forward and backwards. So if I push it forwards, you can see the one that's changing is the y-axis, right? So y-axis is the forward and backwards. So we're going to call it the y-axis position. I just knew that, but from doing this 100 times, but you'd have to figure that out. And we're going to set that equal to the controller. And then we're going to do there's a bunch of things you can do. You can get X, get Y, get Z. These, I've never really trusted to get X, get Y, and get Z. They always seem to do it wrong. What I normally do is I just do get raw axis. And this is just going to return a raw number between -1 and 0 from the port of the axis. And if we look right here, it says axes. The y-axis is port 1. So we're going to do that. So now this double is going to constantly be updated with the position of the joystick, right? So why don't we do this? Now we're going to set the output of the motor every 20 milliseconds, remember, because we're inside periodic, to be the position of that joystick. So we're going to do motor1.set. And we're going to do it again. We're going to do %output. So control mode dot %output, comma, y-axis position. Now, the reason this works is because of the fact that WPILib, the overlords of robot programming, made it so a joystick is between the bounds of, like an axis, is between -1 and 1 automatically. So like the driver station is going to report back a number between -1 and 1, and the motors take in between -1 and 1. So they're like on the same scale. There's no worry. Like fully forward is max power. If it was different, you'd have to like multiply by, like, let's say that the y-axis was between -2 and 2. You have to divide that by 2 to be within the same scale as the motor speed, right? So again, what I suggest you do is you deploy your robot code. I'm going to simulate robot code. There's no difference really. Simulating is just if you don't have a real robot. Since I'm home, I don't have a real robot, but we're going to simulate the robot code. I'm going to close this simulation from before, and I'm just going to enable. This should be starting up. Are we starting up? No. Oh, it closed. I messed it up. So we're just going to close this guy, and then we'll run it one more time. I had two open at once. That's a problem. Okay, simulate driver station and the GUI. Okay, so in here, now I'm just going to enable it, and when I push my joystick forward, you can even see inside the simulator, see it says axis 1 where my mouse is, and you can see it going up and down. Now, at this point, what you should see, again, make sure your robot, you tell kids that the robot's going to be enabled, no one's hands are in it, and you whatever motor you're going to be controlling is not going to be touching anything. No wires are caught in it. If you're driving the robot wheels, it's on the cart, so there's no contact. And at this point, pushing the stick forward should speed up the motor. Letting it go back to its neutral spot should stop it, and then pulling it backwards would spin it the other direction. You can mess around with that. Now that's fun, right? That's a good that's fun. And let's move on to the next thing. So I'm going to stop the simulation, and why don't we get a little bit more complicated here? Let's make a second motor, right? So let's define a second motor. We're going to do private Talon FX, and we're going to call this one motor 2. There's new Talon FX this. So what I'm doing right now is let's I think a good practice for this would be to define a motor on the opposite side of the drivetrain. So if you're doing, let's say if this is the left motor, the left primary motor, because I know on 1923's robot there's 3 motors on each side. You want to figure out the ID for the right primary motor. Any of the motors can be primary. Good practice is what we do is just the left, like the frontmost motor, front lowermost or front uppermost, whatever you want to decide is your primary. So I'm assuming it's not going to be 1, because normally left, it would be something like this. The left motors are 0, 1, and like left equals 0, 1, 2, and then right would be like 10, 11, 12, because they're on the opposite side. But whatever it is, figure out your numbers. I'm just going to call it, let's call it 10 then, just to differentiate it. What we're going to do is let's go back down, and we're going to do we could do one of two things. One is we're going to say, I'm going to retype it. I'm not going to copy and paste it. You could do two things. You can say motor2.set control mode.%output, and then we're going to do, why don't we do negative y-axis position. Now, when you think about it, the motors are mirrored. They're facing opposite directions. One facing in, one's facing out, right? So that means that when you make them both positive, you're going to spin the robot. It's not going to drive forward because they're both going to spin in the same direction, and that's going to cause your robot to rotate. So we need to make one of them negative to make it go forward and backwards. So when we push this code, I'm not going to push it. I'm just going to build it just to show that it works. But when you push this code and enable it, you'll see that this is now making the robot move forward and backwards. If you realize it's going the wrong direction than what you'd like, change it from this to this, right? You can do whatever you want on that. So I'm just going to leave it like that for now. Now, the second way, and the better way to do it, is to do something like this. Inside of robot init, so when the robot's turned on, we want to change something about this motor. Why don't we do motor2.set inverted? I think you can do, is this how it works? Invert motor output. So what this is going to do is we're going to say motor2, when the robot's turned on, do this to the motor. Motor2.set inverted and invert the motor output. So now the motor2 is going to drive backwards of whatever we tell it. And what that allows us to do is we can go down and make these both positive. So we give these both positive values and it's going to drive forward because previously we've inverted motor2. And that's going to stay for forever until you change it or you wipe the settings on it and it goes back to its default, mode. So this is just allowing us to keep things positive, right? So I'm going to leave it like that for now. We'll leave them like that. And let's say you have a second joystick that will allow you to drive the robot in what's called tank drive. So let's make a second joystick. I only have one right now, but let's make a second controller. I'm going to call this left controller. Actually, you know what? We'll do it differently. We'll do it from the stance of a PS4 or Xbox controller. Normally they have two different sticks. So what you can do is you can make it like left stick position, and you can make one of them right stick position, right? So we'll do right stick position. And you could do get whatever the axes are for the left stick and the right stick, you can figure out inside driver station. And then you could do left stick position controls the left side and right stick position controls the right side. And now you're doing what's called tank drive. So if you push both sticks forward, then the robot's going to drive forward. If you pull both sticks back, the robot's going to drive back. If you put them in opposite directions, one's forward, one's back, it's going to rotate. So this is a very simple way to control a robot. And at this point, if you deploy this or build it, or build and then deploy, you should have a driving robot. And at this point, you can put it on the ground. Make sure someone's able to disable it if you mess around with it. But you should be able to drive a robot around, which is fun. So next thing, why don't we try doing a printout? Inside here, there's a lot of times that I'll be working on something and I'll realize that it's not working, and I'll be really frustrated and won't know what's going on, and I'll think that I want to print something out so I can debug the problem, right? So a simple way to do that is using what's called smart dashboard. So if we do smart dashboard.put number, it takes two inputs. One is like the name of what's going to show up. So let's just call this left stick position, and then you put a comma, and then you can put actually the value you want to print out. So what we're doing every 20 milliseconds is we're going to put the number, the left stick position, and with the tag this, so it's going to show up as that. Now actually I'm getting an error, so we got to do quick fix, import smart dashboard. And then I'm going to simulate robot code. You can deploy the robot code. It'll do the same thing, but just to show you, I'm going to run the driver station, and you'd have to open smart dashboard on your computer, so I'm going to do that. It should be installed with FRC, but now when it gets connected and I enable the robot, it shows up just there. And now when I'm enabled, I'm pushing the joystick forward. You'll see it prints out that value. You pull it back, it's that value. And you could this is just for debugging. I just want to show you how to use Smart Dashboard. It's just useful. So like if you're running a program to generate, like based on a distance away, how fast you want the robot to move, it's useful to print this out just so you can debug the problems that would arise. So I'm going to comment that out for now. But let's do a motor that follows another motor. So why don't we define a new motor? I'm going to make it like, let's say on our robot we have 3 motors on the left side. So let's do that. Let's rename this. Let's get rid of this motor entirely. We don't care about motor 2 anymore. It's not important. So we're going to get rid of that from the code. Let's define we have motor 1, motor 2 equals new Talon FX1. We're going to define the other 2 motors on the left side of the drivetrain, let's say, right? So this is the left primary motor, and this is the left follower 1, and this is the left follower 2. So what these motors are going to do is they're going to follow whatever input we give to this one. So we only have to control one motor to make all three move. Because what's happening is inside that gearbox, all three of these motors are connected to one output, and you need them to drive the same speed in the same direction at the same time, or else you're going to break the gearbox. If you spin them opposite directions, they're going to be fighting a gear, and it's going to snap the teeth off, and we're going to be very unhappy about that. So what you do is inside of the teleop init, I like to do, you can do robot init, but I'm going to do teleop init. I'm going to get rid of this. You can do motor 2 dot set I think it's follow, I'm sorry, dot follow motor 1. So motor 2 is now going to follow whatever motor 1 does, and we're going to do the same thing for motor 3. Motor 3 is also going to follow motor 1. And at this point, well, let me get rid of this guy. At this point, whatever we tell motor 1 to do, all three of them they're going to do. So an important thing here is when you're testing multiple motors inside a gearbox, you want to do one of two things. One is drive them really slowly at first and look at the motors and make sure that the colors they're blinking are the same. Green motors or green lights mean that it's driving forwards, I think, and red lights mean that it's driving backwards. So if you see red on one and green on another inside the same, like right next to each other, that means that they're driving the opposite direction and something's wrong. So I'd stop that and call one of us over to figure it out, because you don't want to drive it fast. You want to drive it really slow. You just want to push your stick just barely forward. The other way you can do it is by pulling the breakers physically out of the power distribution board to one of them at a time. So you're only letting one motor get power at a time and then just driving them. And that's just going to allow you to not have to worry about them driving the wrong direction. You can just push it forward and make sure the wheel goes forward on each of them. And we can show you how to do that also. Just pull the breakers out. It's pretty easy. So that's a motor follower. That's important for your drivetrain. Now, if you want to make it so the robot can drive with all 6 motors on the robot, we'll do something like this. We'll do the same thing, but inverted. So I'm going to copy and paste it, just because I don't want to retype it. We'll make this motor 4, motor, oh, not effects, motor 5, motor 6. This would be like 10, 11, and 12. I don't know what IDs they are. This will be right. This will be right. This will be right. And then inside of here, we're going to make motor 4 dot follow motor 3, right? Because that's the right is following the right. Motor 5 dot follow. Did I mess this up? I'm sorry. Motor 5 is following motor 4, and motor 6 is following motor 4. That's what it is. Motor 4. So now we're going to have that. And then the last thing you want to do is, I guess, let's set motor 5. Let's set motor 4 set inverted invert type dot invert motor output. So we're going to invert the motor 4, we're going to invert motor 5, and invert motor 6. So this is going to make them all run backwards. So we're going to do that. Now, what do we want to do next? The next thing we want to do is we want to, I guess, make a button. Why don't we do that? So let's say you have, so now we have a drivetrain. At this point, you should have a working drivetrain. Now, I don't have a robot to test on. The only thing I'm worried about is that these are going to be inverted from the fact that they're following an inverted motor, and it's going to be like double inverted. So just be careful when you're testing these guys, the right side of the drivetrain. If it turns out that like setting them inverted to follow an inverted already motor makes them drive actually forwards instead, just comment these out or delete them. But you'll test that. Just drive slowly at first. Let's make a button to make like the intake run or something. So let's define an intake motor. Okay, private talent fx intake motor equals new talent fx on maybe, I don't know what slot it is. I'm just gonna call it 5, and we're gonna scroll down. Let's go to teleop periodic, right? So every time, oh, I'm sorry, we have to make this thing drive, we're gonna have to do the thing I mentioned before, which is motor 4. We're now telling motor 4 is the lead one on the primary on the right side. So we're gonna set control mode percent output. It's going to be right stick position, which is the variable I deleted, so just re-add it back in. Or if you didn't delete it already, keep it. And I don't know what axis would be on your controller. I'm just going to say it's 2. You just have to figure that out also. So now you have a drive. This is just basic drive right here. You've programmed a robot to drive. Let's make the intake work on a button. So why don't we go to driver station and look at the buttons that are in the controller. I'm just going to press, I'm pressing the trigger on the controller. That's the first button slot. On controllers, the buttons start at 0, just like axes and ports for the actual controllers. So that first button square, it goes down vertically. So it's like all the way down. The list is, this is 0, this is 1, this is 2, this will be like set 10, this is 11, 12. So we're going to look at button 0, right? So why don't we say this? If the controller, because that's what we called our joystick, dot get raw button on button 0, So this is what this is returning is it's returning a true or false, a boolean. So if the button is pressed, it'll return true. If it's not pressed, it'll return false. So if true, basically, so if button's pressed, we'll do intake motor dot set control mode dot percent output, and we'll set it to full speed. We'll set it to full speed, and otherwise, we'll do intake motor dot set, not set inverted, just set control mode. Sorry, control mode dot percent output. And let's make it 0. So we're not gonna run anything. It's gonna stop the motor if the button's pressed. So while the button's pressed, make it run in. Otherwise, stop the motor. So now we have a working intake too. And you could do this. I want you guys to try to do this with every function on the robot. You have a shooter wheel. You have a conveyor. You have a gate, I think is what it's called. I don't remember. You have a few other things. You have the elevator on top, the climber. Don't mess with that just because you don't want to backdrive it and break the robot. But try to make the functions work. And you can even pick up balls and try shooting them now. It's pretty fun to do that. So that's that. Let's think. Is there anything else we want to do? Pretty much that's it in terms of basic stuff. The last thing, once you get the robot driving around and working fully teleoperated and doing whatever you want, I'd say try messing around with autonomous. Try to make a way to make the robot move a certain amount of distance by itself. So this would be done probably inside autonomous periodic, right? Maybe you'd make a variable double distance goal or something, maybe at 100 inches, and then you'd say for maybe like what do you want to set your timer? While like a counter is less than some number, right? You'd want to make the motor. You want to set. Oh whoa, I didn't mean to do that. You want to set the motor to be at a full speed or like half speed. Motor 1. Control mode dot percent output at full speed, and then once it's outside of this loop, and you want to do like num plus plus. So the whole point is that you're gonna have like, I'm sorry, counter plus plus, and num is like based on your distance. So num is equal to some number that you determine, some constant, times your distance goal. So like you're gonna figure out how many times does this loop have to go through to make the robot drive for the correct amount of time to go our distance. And you can make a function out of that or something. Maybe try making doing a bunch of testing and seeing how long you need to drive the robot to go a certain amount of distance, and write some code to get the robot to drive that distance and do it inside the autonomous mode. And you can enable it by going to autonomous and enabling. You can mark out with tape. You can use tape measures. Try to get some basic autonomous working. Do some cool stuff automatically. See if you can get the robot to score some balls in auto, right? So if you have any questions, you can ask us. This has been a basic tutorial on how to use the FRC WPI suite. And yeah, if you have any questions or anything else you want to know, don't be afraid to ask. Thank you.